junction. A function is a very specific relation. Another word you'll hear in math. And a relation is no more than the pairing of numbers together. Pairing of two sets of numbers. I suppose that's why we've been talking about sets. That's kind of a lead into the functions and relations. But if you remember, we're talking about some specific types of, let's say functions. Hold on. Okay, yeah. A relation would be nothing more. I mean, you could think of it in real world terms, where if you're a basketball player, you see a program, and here is the basketball player's name. Let's say that basketball player is I don't know, Christian, and Christian gets paired with his number, which is what?
53.
Right. And Alex gets paired with his number, which is
What is it,
33. And Jacob gets paired with his number, which is 45. Now those are pairings, those are relations. Today we're talking a little bit more specific, and we're talking about functions. And functions came way back in the chapter long ago, 41 actually, where a function is a specific relation. Here's where it gets a little dicey. It is a relation. In order for something to be a function, it must, a specific function that has every member of the domain has, well, I guess I should say, is mapped to, here's the key word, exactly one member of the range. None of that, I repeat, none of that will make any sense to you at all until we talk about this. Evan, honestly, how hard is that to see?
What does that say?
A specific relation that has,
Ace.
Pays every member of the domain that maps. That maps? What was that?
Members?
Members?
Yeah.
Wait, members or numbers?
That has every member, hey, don't criticize my writing, of the domain is mapped to exactly one member of the range. How could you not see that? Now, a lot of what we've done so far are functions, and you see it a lot. It looks like this, where if y equals 1/2 x plus 2, this is a linear equation, right? Remember the whole whatever? Here is, making a table is also called a mapping, okay? And we have our x and y values when we do this mapping. This, the x values are what we call the input numbers. It doesn't write very well. They are the input numbers, and they are also called the domain numbers. Input are the domain numbers. When you're making your table, these are the numbers you put in. You get to pick these. Remember we picked them before? Let's say I picked 0. If I put 0 in for x, half times 0 is 0 plus 2, I get 2. This, the y values, are the output numbers. And they are called the range. Okay, if I put 2 in here, 1 half times 2 is 1 plus 2 is 3. If I put 4 in there, 4 times a half is 2 plus 2 is 4. If I put 8 in there, half times 8 is 4. And I get 6 right there. Okay. Here is the deal, Bobby. What this tells you here, well, here's another way. Let me show it another way. Let's do it as what we call the actual mapping. Instead of writing it in table form, I'm going to write it in using these little circles. This is the domain, which is the input. This is the range, which is the output. If I put 0 in the domain, I draw a little arrow over here, that equals 2 over here, right? If I put 2 here, I draw a little arrow, that equals 3 over here. If I put 4 here, I draw an arrow, that equals 4 over there. In order for something, Ariel, to be a function, you can only have one arrow coming off of this going to a number over here. Okay, you will not, this would not be a function if you saw 0 have 2 answers. Automatically, that would not be a function anymore. Okay, as long as it just has one arrow coming off the domain, okay, it is a function. Now people get confused because notice I didn't say this. Could this happen? If I have a 5 here and 5 goes to 4? Yes. Different domains can go to the same range, but you can't have different ranges going to the same domain. That's the dealy Bobby there. Okay? So if you're doing this number, you can have different x's being the same y, but you can't have 2 different y's being the same x. Nobody will catch on to that shit, whatever. That's just the way it is. Now, when you graph something like that, let me show you. Maybe I should show you an example of. Here, let's look at this. Let's make a relation here. Let's say y equals x squared, and let's make one that says y squared equals x. Let's see if you can handle this here. Sometimes you can or can't handle the truth. Let's make a mapping and graph these. Doesn't that sound like fun?
Yes.
Yes. Let's do a whole bunch of stuff with this. Because you know, if you entertain me with this, life will be good. So here, let's do this one first. Let's make a table, then we'll make mapping, and then we'll make a graph. Here's my domain, here's my range. Somebody give me something for x there. Just something simple because I don't want to get too crazy, Grace.
0.
If I put 0 in for x and squared, I get 0. Another number for x. Ariel?
2.
2. If I put 2 in for x and squared, I get 4, yes? If I put Ryan in for x, 3. Good, we're just keeping it low. And if I put what in for x, Eli? 4, I get 16, correct? Okay, now, if I make this a mapping, let's do the little circle thing. I have 0, 2, 3, and 4 here. I have 0, 4, 9, 16 here. Ka-chung, 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 ka-chung. Looking like a function to me, yes, looking like a function to you. If I graph this on a number line, I have 0, 0, 2, 4, 3, 9, and 4, 16. My graph looks like this. A little off. Looks like this. Let's do it a different color, shall we? Yes, we shall. Oops. Let's try that again. There's the graph of that. By the way, that is not a straight line. Straight lines don't have anything to do with functions. They do have to do with proportions, but not functions. Let's do the second one. Are you excited?
Kind
Oh, whoops. Whoops, didn't want that. Oh, boy. What I wanted to do is this. Okay, here we go. Here's my table. Here is the table. Now, careful with this for me, people. There's only certain numbers that are going to be worked out for here. By the way, if y squared equals x, what does y equal? Jake? Square root of x. Correct? So you want to give me perfect squares. So we can use 0. If I put 0 in for x, what number times itself gives you 0? 0. How about 1? Now be careful with this because yes, the answer is not only 1, but what other number times itself gives you 1? Negative 1. Negative 1 times negative 1 also gives you 1. So for 1 you get 1 and you get negative 1. How about, let's go 4. If you put 4 in for x, what number times itself gives you 4? 2, but not only 2, also negative 2 times negative 2 gives you 4. Oh, how come this didn't move, honestly? So now, let's look at our mapping here. Anybody? Didn't really shrink with my stuff. If I do my mapping, I have 0, 1, 0, 1, and 4, right? And look what happens. 0 goes to 0, but 1 not only goes to 1, it also goes to negative 1. And 4 not only goes to 2, but it also goes to negative 2. This, because of what just happened there, is not a function because one thing here has 2 arrows going over to 2 things there. About that? Yes.
Wouldn't be a function.
What's that?
It wouldn't.
Oh, and we should have done for this one here, if I would have put negative 2 in for x, what is negative 2 times negative 2? So I could put negative 2 here, and it goes, wait, am I on the wrong one?
Yes.
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 Yes, I should have been on this one. No, well, forget that. Let's go there. Where was Jake? What was your question?
I said so. It's not a function.
This is not a function. If you graph this, take a look at what this looks like. Can I move that somewhere and graph it? I'll go to a different page and graph it. What were my numbers? 0 was 0, 1 was 1, and 1 was negative 1, 2 was,
No, 4.
4 was 2, and 4 was negative 2. So when I graph this, 0, 0, 1, 1, 1, negative 1, 4, 2, and 4, negative 2. When you graph it, it looks like this.
That's how you get.
Oh, that's what that is.
Okay. Now notice the graph of x squared, which we just did there. If you were graphing x squared, it looks like this. X squared looks like this. The square root of x looks like that. Now, here's the whole point of this, because we gotta go, because I gotta get there and do some whatever stuff. To tell if something is also a function, children, write this down. We have what's called the vertical line test. Okay? Because we know that, see, these are all my x values on this line right here, right? Those were all my input numbers. Every input number can only have one output number. Okay? Every input number can only have one output number. That means this. If you take and draw vertical lines all the way through this thing, lines that are parallel to the y-axis, something is a function only if it doesn't cross any given line more than once. In other words, as soon as this crossed here in two places, this is not a function. A function has to look like this, where it's only going to cross every vertical line once and only once. Okay, it's vertical line test, not horizontal, because horizontal doesn't matter, vertical does. So if you see something that looks like this and you draw a bunch of vertical lines and that graph crosses that line more than one in one place on the same line, it's not a function. So if you see something that looks like this, function or not? Function. Why? Because I can sit here and draw straight up and down lines all I want, and that is never going to cross on one or the other. But if I do this and I go function or not, no, because as I draw my vertical lines, right here it crosses that vertical line actually three places at 3 times. Okay, that is the favorite vertical line test. To test for functionality. It's functional too.